A digital transport is basically made up of three parts. This input, so the CD pickup or CPU reading from some sort of media, and the output stage. Obviously, the input is connected to the output, but all the processes needs to be synchronized, and they work only if there is a master clock. And the master clock, that's the kind of the pivotal part of the digital transport. The master clock is like a pacemaker. The pacemaker provides a certain frequency at which all the digital processes are happening. They are synchronized to work at that frequency. As the name says, master clock. Master clock defines all the digital processes. It dictates how data is being converted, processed, streamed, whatever, transported. That basically defines the character of the digital. That master clock is inside the digital transport, not the DAC usually. And those DACs that have an additional clock that reclocks everything, they're just corrective processes. And these corrective processes, they all destroy musicality, so you can't repair it afterwards. One cannot improve the quality of a recording. So reclocking is just an attempt to improve something. Attempt to improve something means correcting something, making usually things worse off than they are. Well, we don't need to reclock anything if the master clock is of highest quality. So if anybody wants to have the highest possible potential on the playback of digital, the missing element is the right type of the digital transport. Wrong type of digital transport is going to make even the best DAC sound very mediocre. When we were designing our valve digital transport, we started off with a CD player on the design of the master clock. Different power supplies, different components, everything that goes into a master clock pretty much defines the rest of the character of a digital source. So that being the DAC itself. My conclusion was that the way basically the data being served into the DAC, the way the DAC is going to sound. That's why from very early stage I understood that we need to make the digital source as good as possible so that our DACs can excel. As we moved on, it proved rather difficult to find a supplier for a CD pickup that would satisfy us in terms of the quality of these CD pickup mechanisms. The CD pickup mechanisms made nowadays, they're all more or less the same. This is the heritage of the CD-ROM PC type of computer era. Even if the whole body is made of metal, then they have a plastic lens on them, and that pretty much defines the character of your digital transport. We actually gave up and decided, why wouldn't we substitute this CD pickup mechanism with a servo with a CPU and a different media. And the CPU should be reduced to completely minimum processing, so just like the early CD players, and so that we can get the maximum direct character out of the playback, just like with analog. Unlike most of the companies that produce those streamers nowadays, which are essentially normal computers with running some very specific operating system. They have a high processing power, which is absolutely unnecessary and has only sound degrading property. The less processing power one has, the smaller the demand for the power supply to deliver the current, usually. That means we can pay attention to create higher quality power supplies. The power supplies is the key to the master clock, to the CPU and the output stage. Everything can only be as great the power supplies for all these three elements is. In the early days, I could clearly observe by experimenting with CD players what part is affected how by which material and component. We have the third element, which is the output. And the output stage is equally as important as the previous two, as the master clock and the input. Now, the output stage is the connecting part between the digital transport and the DAC, and the output stage is supposed to drive the DAC. Even the early days when we experimented with CD players, the first revelation on how great a CD player can sound is by just substituting our own master clock based on valves. So a stock CD player with an aftermarket valve master clock sounds totally different than the stock CD player. And the clarity, the transparency, the dynamics, the softness, the warmness, everything that we associate with analog is being preserved and enhanced by the materials and components we use in the output stage. And everything that I just mentioned is defined, whether it's the output stage, the input stage, the master clock, is defined by the quality of power supplies. That's why you're going to see in our top-end digital transports more valves being used in the power supplies rather than just the frequency generators or some output drivers or whatever we have there. One of the reasons why we use valves, particularly in the master clock, is because of its defining sound character. Valves can be operated in on-state condition, where all transistors are kind of on and off. They are semi-conducting, they're not continuous. So when we want to achieve this fluidity and liquidity that we associate with analog sound, that's where the valve comes in. This is the crucial, important aspect that nobody else makes, is having master clocks based on valves. Or I mentioned in earlier videos how each and every material has its own sonic character. So silicon has a character, germanium has a character, selenium has a character, and transistors themselves as semiconductive devices have a character. And valves have a more analog sound character than semiconductors have. We use maximum number of valves inside our VDTs. As the name implies, valve digital transports. Wherever we could use a valve instead of a semiconductor, we try to use a valve. The advantage of this SSD over CD lies in its property of data redundancy. And the data, once it's written on an SSD, can last forever because it's only being read from it. One doesn't need to rewrite it and write again. So as long as the data are not being constantly rewritten on SSD, it can technically outlast a CD because there's nothing mechanical rotating or moving in those SSDs. Now we kind of moved away from these modern CD pickups. Our biggest challenge is to reduce the processing power further. So the best way, is to reduce those processes is to have an operating system that is really pure, that is only designed to do one thing, that is real-time kernel, and that is basically stripped down to absolute minimum and does only one thing, just reads the data from the source, from the storage, and then gets the data processed, transported to the output. And that ensures that we have the most direct, unprocessed sound akin to the early CD players. And that's why we opted to go for local playback. It doesn't mean that our VDTs cannot stream. Oh yes, you can stream. For music discovery, that's a great thing. But for maximum quality and playback, local playback is the option one should really consider. There's no other alternative. The reason why the analog playback is so superior to most of the digital nowadays is because the analog remains to be a local playback. You're not streaming your vinyl or tape from anywhere. You're playing it back locally. That's why the sound is least processed and direct, unimpeded. It's coming through our speakers, being transduced to our ears and our brains. And the same obviously applies for the digital transport. So our VDTs are designed in such a way that they operate with minimum processing and minimum correction. Now, if we combine our DACs with our VDTs, one has a complete product. That digital source becomes indistinguishable from the analog playback. They're like the missing element to the digital playback, and they provide that character for the analog, the direct, the vivid, the lively, the musical sound that everybody would love to have.